Hello, one of the things I wanted to test with this sexy twin hopper plane was what happens when one of the motors fails. I guess the first question would be, does it keep flying at all? But I wasn't really too worried about that. I was more interested in seeing what Ardupilot will do when that happens. Is it going to freak out and do something crazy? Or is it just going to take it in its stride and not even care? And it turns out it doesn't care. It just keeps operating pretty much as normal. It's kind of even hard to tell that anything's happened. Possibly because this plane is so well designed. If we look from the front, you'll see that I've placed the motors about as close to the middle of the plane as they could be. I guess that's what we would do normally, but yeah, just made sure that I was doing that because I was thinking about doing this test even way back when I was designing this plane. So that's what we're going to look at in this video, and there's also one other thing that we're going to test that is related to missing motors and unbalanced thrust and so on, so keep watching. So if you watched some of my earlier videos about this plane, you may know that I'm taking the S-bus output from the Ardupilot flight controller and I'm bringing that into my I/O mixer to do, to set the endpoints for the servos and to do the slow movement for the flaps and a few other things. And this is how I'm handling the throttle so far, or have been up until now. There's nothing really special about it. This is part of, so that's the whole program that's running on the twin hopper there. And this is just the bit where the throttle is being managed. And there's no logic in between this really, so this serial RC input brings in the S-bus signal, channel 5 in this case, and it just passes it directly to the left and right motors equally with no change. And that little bit of video that I showed you at the very beginning of this, switching off one of the motors, was done by placing using another channel. So this is my throttle channel, and then we have the switch channel, channel 1, and we're just deciding here whether we want to use the RC throttle as normal or we want to use 0 for the left motor. So that's how that was working. Oh, by the way, I've made a little thing here. There's a new panel type called storage where you can change, you can just save your programs online in the database, and then you can just fetch them like this. So that's how I'm switching between those programs. One problem with this setup here though is it's going to very abruptly cut the throttle when I flick that switch. So it's going to one of those motors is going to go from potentially full throttle, maybe depending on what the autopilot's doing, to 0, and it's going to try and break that prop very, very quickly. And it just seems a little bit harsh to do that, and I didn't really want to do that. But I was watching a video by Uncle Bruce the other day, and he was reviewing the Jumper something 20S radio, and he looked at the two dials there in the middle, and he said, "Oh, nobody uses those." And that reminded me, I have two dials on my FlySky radio that I could use to switch each of the motors off individually, and it wouldn't be so abrupt because the dial would naturally be a little bit more of a slower change. So that's what I did here, and we'll just ignore that bit there. So this is the throttle stick input, and it goes into both of these scale nodes there, and then we have a dial. This is my left motor scale dial, and that's my right motor scale dial, and this scale just basically multiplies those two together. So when I turn one of the dials down, we turn that motor off, and when the other dial will turn that motor off. Oh, that didn't break. I wonder what happened. That's weird, it seemed to desync there. Okay, just double check my motors are on full power for the takeoff. No payload today, so this should lift off pretty easy. Whoa, right up there quickly. Alright, so I'm going to turn the right motor off here. And that's with no stick inputs or anything, so just... So it's pulling to the right, definitely. Okay, I'll turn that motor back on. Okay, let's see what happens in auto mode. So it still needs to climb, yeah. Alright, and I'll let it do one trip out there, so that it's all up to altitude and it's like, got everything adjusted.
and then as it comes back over where I'm standing.
Sorry, I'm going to have to interrupt you there, past Chris. After spending half the morning doing this, unfortunately there were no logs recorded by Ardupilot, so I really had nothing to show for this, and I had to do it all again a few days later. But I'll just show you this landing here while I'm talking, because that turned out kind of nice. And I'll also play a little bit of video that I recorded at the time between these flights, and that will explain what I was thinking there, and also what is the second thing that we're going to test in this video.
Okay, well, that was originally all I was going to test in this video, but I cut the flight short, so I've got enough battery for another takeoff, I hope, because I saw a video from Andrew Newton, actually 2 videos from Andrew Newton a few days ago, where he was testing the difference between, what was it? Difference between having the props rotating in at the top like that, like I have them here, or rotating out at the top, and whether it really matters if you lose a motor in either of those situations, or which is worse. Now, in theory, obviously one of those is better. The way I have it here, having the props coming in at the top is by any objective calculation better. But does it really matter? How much better is the question. And I kind of think it doesn't matter that much. In fact, when I built Big Red, I only had props that went the same way, and I was a little bit worried about it. And I called up Uncle Bruce and asked him about it, and he said, "Don't worry, doesn't really matter." So I'm guessing at this scale, doesn't matter. And yeah, well, anyway, let's give that a try, because it won't be too hard for me to change. All I need to do is undo this bolt here, swap the props, and then swap one of these connections under there. Actually, let me just disconnect the battery before I fiddle around with my hands over there. Yeah, so let me swap these over, and let's see if this battery can give us another launch. Okay, so swap those props over now, and maybe you can see they're going to be propelling us when they go that way, like so. And to be honest, I'm not really expecting to be able to tell much difference from the previous flight just while I'm flying and looking through the FPV goggles or watching the plane or anything. It's really only, I expect, it's really only going to be when we look at the log afterwards that we might see a little bit of difference. So hopefully this will be a little bit more of an empirical test than what Andrew did, because trouble with what he was doing is, as a video demonstration, like, we can't really feel what's happening, so we're just sort of dependent on him to describe what he's feeling. And the problem is he's a pretty experienced pilot, so his fingers are automatically going to do whatever needs to be done to correct that plane, which is okay, but then we can't really sort of tell that very well. So hopefully the log, looking at the log, will give us some actual measurements and numbers maybe. The other thing about what he was doing is, it's a very small plane, and I kind of suspect that maybe at small scale it's not such an issue. The big thing is how much rotational inertia one motor carries relative to the rotational inertia of the whole plane. And yeah, I don't know. I just think even at this fair bit larger scale than what Andrew was doing, even at this scale, I don't think it's really going to matter that much. Anyway, let's give it a test.
Well, this is really annoying. This SD card log that was working perfectly fine last time I used it, as you can see, March 31st, we have a 174 megabyte file. This was the endurance test that I did with that large lithium ion pack, like an hour and a half, actually slightly more than an hour and a half of flying. That seems to be working fine. All these other files here are fine. Just today though, these files that we really wanted to look at, well, one of them doesn't even exist, and the other one is only, well, it's a 0 byte file. So as you can imagine, that was pretty annoying, and as a backup I decided to use the IO mixer to do some logging as well. Now, it can't log all of the information that the Ardupilot system knows about. It can really only log what's coming through the S-bus line, so that's these green ones here we can log. And if I zoom out a little bit, so this is the program that I'm running on the for the rest of this video, and it's just basically taking each S-bus, so serial RC is the S-bus, and it's just putting each channel of that straight into a log output. So you could think of this as like a line, or a column, sorry, in a CSV file, and every 50th of a second one of those values is going to be written to that CSV file, or not one of them, 10 of them. We've got 10 10 channels that we're logging there. By the way, there's no onboard logging on the I/O mixer itself there. So the way I've been doing this is I use this external open log thing. It's basically a little Arduino, and on the back of it there's a, well, under that sticky thing there's a SD card writer, and it just connects with a little like servo cable onto the I/O mixer from there. In the rest of this video you'll see at the bottom of the screen the RC inputs, and this is not always RC inputs. In manual mode it's going to be directly what my fingers are doing. In fly-by-wire A, the throttle are going to be what my fingers are doing, but everything else is going to be augmented a little bit to keep the auto level happening. And then when it's in auto mode, none of the inputs are going to be directly from my fingers, so just keep that in mind.
Alright, so second attempt at this, and this time I have my I/O mixer logging on as well, so we should get at least one log off this time. And let's face to the right a little bit more. And so I didn't change the props from last time, so the props are still spinning outward at the top for this first flight. Anyway, flaps on. Oh, something doesn't feel... It was a bit vibraty, wasn't it? Oh, I can hear it vibrating too. Wonder what happened between the last flight and this one. Oh, it's really vibrating. Wow. What is this? Oh yeah, I'm pretty sure it's a left motor. So I think what we'll do is just for the entire duration of this flight, the auto part of it, we'll turn that left motor off, because I think that's the one that's vibrating. And that was also the one that wasn't braking properly last time. I noticed sometimes it was freewheeling, which kind of ruins our experiment. But anyway, let's pop into auto mode there. And let's turn... Alright, so left prop is off. And I'm just going to let it do one circle this time, because last time when I did this, we ran out of battery a little bit. Well, we got pretty low on battery, and I didn't like that, so don't want to do that again. We want to make sure we've got enough to do 2 launches and landings. Alright, so I'm just going to leave... Oh, I can see the shadow on the nose of the plane in my FPV view of the left prop, so that looks like it's properly braked this time. It's spinning, but it's spinning quite slowly. So I'm pretty sure that means it's braked, which means that this turn here, right about now, we're going to turn to the left. That this should be quite an easy turn, because the right motor is going. And likewise the turn just ahead of us. Whoa, what are you doing? Oh, it turned too far. It turned about 30 degrees too far, because it had that motor going to give it extra yaw input to the left. Yeah, that makes sense, doesn't it? Alright, this should also be an easy turn. Let's see if it turns too far this time. Maybe a little bit too far, yeah. Not much though. Okay, it's only pulling 14 amps here, so we might have a little bit of lift again. It seems like not much current to hold altitude. Yeah, it's flying just fine. Looks normal from here. It's not quite close enough for me to see the prop that's stopped. It just looks like it's flying normally. It's quite slow though, isn't it? 40 kilometers ground speed. Seems to be comfortable enough though. It's like only pulling 9 or 10 amps. So I mean, I guess that's fine. Wow, it looks like it's just hanging in the sky here. Come on. I guess there's a wind up there going against it at the moment. That's probably why. Alright, now about here we have to do a right turn. This is not going to be so easy, because only the right motor going is going to try and turn it to the left a bit. But Ardupilot seems to be handling that just fine. And yeah, I don't hear the vibrating noise now, so I'm pretty sure that left motor that we stopped was the one that we should have stopped. That's the one that was vibrating when I fixed that little collet thing on the back of the motor the other time. Alright, so this turn should be a bit difficult too, but no, it's doing it alright. Okay, so just after it straightens up here, I'm going to put that motor back on. Like that. We should have both motors going now. And I'm also going to put it into fly-by-wire A and cut both motors off and just glide it. I have quite a bit of altitude here, so I should be able to just glide that down to land, I think. See how it goes. Well, I have to remember there was a fairly strong headwind. So let's start turning early. Wow. There's a little bit more wind today than there was last time, unfortunately. But it's going in a nice direction for landing. It's like the wind is coming straight ahead of the plane at the moment. So we're heading perfectly upwind at the moment. And not sure if we're gonna. Yeah, we're too high, aren't we? Very, very too high, I think. So let's see if we can do a little turn with the old rudder. Quite a bit of rudder here. That's better, but let's try again to. Still too high, I think, but let's see what happens. I have no flaps on, so I'm hoping to carry the speed here. Oh no, it's not going to make it to me. That's right. Oh, and I just realised I don't have my hat cam on to show you the landing, sorry. You'll just have to look at the onboard view. Okay, so now we have the props turning in at the top. Whoa. Oh, I think I was just being a little bit lethargic with the throttle there. And it wouldn't have helped that the battery is a little bit lower than I'm used to for takeoff as well. But anyway, let's turn it around and just try and retrace our steps that we did. Alright, so right about here we'll put it into auto mode. And we'll let it just settle a little bit. And now I'll cut the left motor here again. Okay. So that's pretty much what we did last time. So the weather conditions should be pretty much the same as what we did before. There was a little bit of a break because my dolly broke, unfortunately. One of the wheels fell off and I had to go back home and fix it. So it's about 25 minutes, maybe even half an hour since the last flight. But the weather hasn't changed that much. I think the wind might have dropped off a little bit. Okay, so we have a turn coming up here. Left turn, please. Please turn left. There we go. And that should be the easy one that turns us too far to the left, and it has again. Not quite so much this time, I think. Alright, so just wait for it to do this turn. This is the difficult turn. There we go. Yep, that's fine. Kind of slow, but it's managing. Alright, so let's bring this left motor back online. Looks like we did everything alright. Just let it settle there, and okay, left motor coming back on. You're to the right a little bit there. Didn't change the current much, that's interesting. Just stayed where it was. But anyway, I'm going to have to land it now. I've been thinking about trying to land this FPV. Not sure if it's really a good idea, but that's what I'm going to do now. I've just decided, I was just thinking about it. Alright, so we go into fly-by-wire A, throttle back to nothing, and I'm going to put one flaps on, just so that we can slow down a bit. Actually, I might put two flaps on here, so two flaps, ground speed 22, that's not very, oh man, it's going slow. So I'm pushing the nose down, and I'm going to turn to the left a little bit because we still have too much distance, I think. I mean, too much altitude. Oh, but we have to keep in mind it's a headwind coming down the airstrip, so the other thing I have to keep in mind is that I'm standing right next to a fence, so I can't judge. Okay, back to one flaps now. I can't judge where to land without hitting the electric fence until I can see myself. No flaps. A little bit of motor. Still can't see myself in the FPV view, unfortunately. Okay, there I am. Okay, I see. So we want to land just past me. Wow, it's going so slow. Oh! Oh, that was weird. I had no elevator travel. I mean, no elevator authority. I guess I was just going so slow that the elevator wasn't really working much anymore. Okay, looks like we've got everything back in one piece. So let's hope that we got some logs to look at this time.
Well, I'm pleased to report that all of the logging worked for both of these two flights, and you would have seen the little sticks display at the bottom of the screen just before. That was coming from the IO mixer log, and what we're looking at here came from the Ardupilot log itself. Now, I didn't really think too much about what data we were going to have a look at here. I just assumed there would be something we could look at to determine which of these flights was having more difficulty with the missing motor. But yeah, to make a long story short, it just doesn't matter as far as I can tell. It's really hard to see anything that's significantly different. But anyway, what we're looking at here is a top-down view of the flight path, and the white dashed lines are the, well, not this one actually. This is the home point there, and the other white dashed lines in the figure 8 are the flight plan, and the yellow line is the path of the plane only in auto mode. So there were some other parts to this flight, of course, where I circled around and landed, but we're just looking at the parts where I switched into auto mode. And actually you can see a little bit of orange in the top, right up in the top left there. That is the last little bit of fly-by-wire A just before I switched into auto. And you can see that when it switches into auto, it goes pretty straight for a good while. So at this point here, what it's trying to do is go to that point there initially. And you can see it's pretty much making a beeline for that point until here, which is where I switched off the left motor. And then it kind of swerves to the left, and it keeps swerving for quite a while, and then finally it kind of gets back to where it was supposed to be going. There's a circle around this waypoint where if it gets close enough it's just going to turn anyway, so it doesn't need to go right to that corner. So that's what it does, and it swerves quite widely around this corner. This is going from directly downwind to approximately crosswind, so I think maybe that's why that happened. But after that, the rest of the flight's pretty nicely on track, and there's basically no problems. And likewise down here, it's almost the same. My starting position was slightly different. This is where I started for that one. But again, we go straight for a little bit, and then here's where I switch the motor off, and we swerve again. But basically, it's the same kind of thing. A little bit wider turn here. Perhaps that was like I was saying, the wind was a little bit different perhaps between them. That's all I can really see that's different, and the rest of the flight, again, it's all on track. Maybe a little bit wider here as well, but nothing majorly different really. And regarding what else we could look at, all I could really think of was what is the roll, pitch and throttle going to have to do to counteract the slight difference in thrust, and maybe a little bit of torque from the motor that's going to be different. So what we're looking at here is, again, only the auto part of the flight, the autonomous mode section. These large spikes here are where it turns to, where it like swings the ailerons to one side to turn around the corner. So there's two of those there and two of those there, and you can see these ones are turning left and these ones are turning right. But overall there's not a whole lot of difference visible. If anything, there's just a little bit of a bump here, which could just have been the wind, I think. So blue is roll, orange is pitch, and then green is throttle. We can see from this that the mean roll, 1555 there and 1562, it's not really that significantly different. But somebody may be already thinking, wait a minute, this mean is averaging out the whole of that circuit, and at some points the plane was going downwind, and some points it was going upwind, and then it was going crosswind. And if you do a figure eight, you're always going to be taking two left turns and two right turns, so it all evens out. So maybe looking at this mean is not very useful. So what I did next was I just clipped out this section here, so the plane goes down and then up, and then from this point here it's going left and down like this to there. So I just clipped out this straight section in each case, and that looks like this. So this is the same direction relative to the wind, same height, similar speed, no turning corners in this one, and it's just a steady straight leg of travel. And again, in this case, these numbers really don't change much. And actually the roll is the most similar. That's the opposite of what I expected. But anyway, that's about all I have. If you have an idea for what data values from this log we could look at to get a better idea of which one of these flights might have been more efficient or whatever, let me know, and maybe I'll have a look at those. And I don't think I'll make a video about that, but if you want to just mention that, I'll reply in the comments maybe, and see if there's anything else that could give us an idea. But anyway, that's all I have for this video, so thank you for watching. Hope it wasn't too boring. So yeah.